Assalamualaikum warahmatullahi wabarakatuh. My name is Syamsul Akmalami Suzaini. My matric number is 2413111000 and I'm from machining. Okay, today I want to present to you guys the project of computer aided engineering, and my mini project title is Projector Case Analysis. Now we will start with introduction. We know that projectors are very important in various kind of industry, school, company. Okay, and for safety reasons, some of them are used cage to hold a heavy project. As we know, some projector are placed on the top of the high ceiling, and weakness of these cages, it sometimes can't hold a heavy masses of some projectors. And this mini project is used to make and create a stronger and safer design. And for this, we will use CAE that will help in design optimization using NC software and CATIA. Objective: firstly, we will conduct static structural analysis on the projector cage. This will perform a detailed analysis using CAE tools such as NCs to evaluate the von Mises stress, total deformation, and safety factor of the existing projector cage design under specific loading condition. Next, propose and implement design improvement. Modify the original design by adjusting material properties, increasing thickness, or adding reinforcement such as additional pivot pins to improve the cage's ability to support heavier projectors. And thirdly, evaluate the effectiveness of design changes. Compare the original design with the modified design based on the analysis results, specifically focusing on stress reduction, improved displacement control, and a higher safety factor to enhance the overall structural integrity of the projector cage. Project scope. For the static structural analysis, we're going to use NC software, and we're going to use structural steel and titanium alloy for the material. There will be 3 design configurations: main design, design 1, and design 2. Fixed support applied at the top of the mounting plate. Bonded contact defined between all interacting components, and 147 newtons downward load applied at the inner place where the projectors are placed. Boundary conditions and loads. As you can see on top, the first picture, there will be the fixed support applied at the top surface of the top plate. This represents rigid attachment of the pole to the ceiling. And for the bottom picture, there will be put the static load applied at the place projector. Load applied in the negative Z direction, which is it's gonna go downward. So this is the methods that we use from zero till the final of the project, and I'm gonna explain it and show it to you guys using a flowchart. So firstly, we're gonna use CATIA software to do the CAD modeling for the 3 design, and then we're gonna do the initial design assessment, and we're gonna identify the weakness, which we locate a critical stress point, and we have 2 design improvement, which is design improvement 1 and design improvement 2. And then we reanalyze again the improved design, and we compare all the result, which is stress, deformation, and safety factor. And finally, we're gonna do evaluation and conclusion. Design configuration. Firstly, the main design, which is the original design that we follow from the picture or the dimension from the original product. And secondly, the optimized design 1, which is we increase thickness and add more pivot pin. And for the optimized design 2, we keep the original thickness, but we add more pivot pin, and we use titanium alloy for the structure material. So here are the main design, where the original design is. So as you can see, we have 2 flat face support on the top of the pole, and then the standard thickness for every part, which is all part using same thickness, which is 2 mm. Design 1, modified design 1. It has 5mm of thickness for every part. And from 4 pieces of pivot pin, we increase the amount of pivot pin to 8 to make sure it hold the cages properly. And this is aimed to strengthen the whole plate. Design 2. This is the modified design 2. We use the standard thickness of 2mm, but we add more pivot pin, which is 8 pieces of pivot pin are used in the design 2. And these are aimed to strengthen the bond between the plate and the cages, but at the same time, we don't want to make the design heavier, so we use the titanium alloy. So this is the result from our compare result data. And for main design, we got 90.2226 megapascal for stresses, 0.88463 mm for the deformation, and 2.0008 for safety factor. For improvement 1, we got 15.483 megapascal for mid stress. For the deformation, we got 0.059409 mm for total deformation, and safety factor of 15. For improvement 2, we got 92.361 MPa and 1.7572 mm for the total deformation, and 10.096 for safety factor. And for the picture down there, you could see I have separate all the stress, deformation, and safety factor in 3 bar. So there are the comparison that you can see. Discussion. Von Mises stress. Von Mises stress helps us understand how much stress the material is under. If this stress gets too high, the material can fail. In the original design, the stress was 90.226 megapascal, meaning some parts of the projector cages were at risk of breaking under heavy loads. After improvement 1, thicker material and extra pivot pins, the stress dropped to 15.843 megapascal, showing the cage was much stronger and safer. The added thickness and pivot pins helped spread the force more evenly. Deformation, bending and stretching. Deformation shows how much the cage bends or stretches under force. More deformation means the cage is more flexible, which is not ideal for heavy loads. The original design deformed by 0.88463 mm, which way too flexible. With improvement 1, the deformation decreased to 0.059409 mm, meaning the design become much stiffer and better at handling weight without bending. However, improvement 2, which using titanium alloy material, increased deformation to 1.6572 mm. Even though titanium is stronger, it's more flexible, so the cage bend more than with improvement 1. Factor of safety. Factor of safety tells us how safe the structure is. A higher FOS means the cage can handle more weight without breaking. The original design had an factor safety of 2.77, which was low and meant the cage could fail under heavy load. Improvement 1 increased the FOS to 15, meaning the cage could handle much more weight safely. This is 100% improvement. Improvement 2 gave an factor of safety of 10.096, a good improvement over the original, but not as high as improvement 1. This is because titanium alloy, tough strong, cause more bending. Material choice. The original design used structural steel, which was strong but not stiff enough to resist bending under heavy weight. Improvement 2 used titanium alloy, which is stronger but also more flexible, leading to more deformations. This shows that while stronger materials like titanium can improve safety, they might also make the design more flexible, which can lead to more bending under heavy load. Conclusion. Static structural analysis successfully evaluate the projector cage. Design modifications can significantly reduce stresses and deformations. Factor of safety increase indicating improved structural reliability, and finally, modified design one achieve the best performance amongst all designs. Thank you.